Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2017, paper 3, higher tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. I've been given 2 column vectors and I've been asked to find the vector 2a plus b. Okay, so 2a plus b is going to be 2 lots of my vector a, which is minus 4 minus 1, plus 1 lot of my vector b, which is 3 minus 1. So I need to then look at 2 times minus 4 plus 3. For the top number, 2 lots of negative 4 is negative 8 plus 3 is negative 5. And then I need to do 2 times negative 1 times negative 1. 2 times negative 1 plus negative 1. So 2 lots of negative 1 is going to be negative 2 plus negative 1 is negative 3. So the vector I'm looking for is that one, which is that one there. Question 2. Which of these values of n makes 2.7 times 10 to the n a cube number? Well, if you have a look at the digits 2 and 7, we know that 27 is the cube of 3. So if we can make this number into 27, then we've got a cube number. So to turn 2.7 into 27, you need to multiply it by 10. And if I've got 10 to the power of n is equal to 10, then n must be equal to 1. So it's that one there. Question 3. Rearrange 2x equals y over w to make w the subject. Okay, well if I've got 2x equals y over w, then I can move my w by cross multiplying it up here, and I can move the 2x back down where the w was, and I'll get w is equal to y over 2x. So which one is that? It's that one. Question 4. Work out the bearing of C from A. Just be clear about which point is your starting point and where you're going to. So we are starting from A and we are going to C. So what is that? Clockwise from north, I'm going to get 130 plus 80, which is 210, isn't it? So the bearing I'm looking for is 210, that one there. Question 5. A coin lands on tails 200 times. The relative frequency of tails is 0.4. Work out the number of times the coin was thrown. Okay, now we can use the fact that expected number of successes, that's going to be the number of trials times the relative frequency. Now here we know the expected number of successes is 200, and we know the relative frequency is 0.4. What we don't know is the number of trials. So we can rearrange this to find it, can't we? So let's call the number of trials n. The relative frequency is 0.4, and the expected successes is 200. So rearranging for n is going to be 200 divided by 0.4. Okay, my calculator says that that's 500. So there are 500 trials altogether. Question 6. How are the whole number solutions of A and B different? We've got A, which is solve 3 is less than or equal to 3x, which is less than 18, and B, which has 3 is less than 3x, which is less than or equal to 18. Okay, now notice everything there is a multiple of 3, so I can simplify both expressions by dividing everything through by a factor of 3. That tells me 1 is less than or equal to x, which is less than 6, and B gives me 1 is less than x, which is less than or equal to 6. Okay, so the values of x which satisfy A are going to be the values 1, 2, 3, 4, and 5. And the values of x that satisfy B are the numbers 2, 3, 4, 5, and 6, because the endpoints are slightly different, aren't they? Okay, so what's different about them? I suppose A contains so I'm going to say A, so A contains 1 but not 6, and B contains 6 but not 1. Okay, probably overkill, but I've covered everything now. Question 7a. The length of a pipe is 6 meters to the nearest meter. Complete the error interval for the length of pipe. Okay, well, if it's 6 to the nearest meter, then the next one up on the scale would be 7, and the one below it would be 5. And the ones closest to 6 then would round to 6. So the ones in here. Okay, so where does the boundary lie? Halfway between the two of them, 5.5 and 6.5. So we want our length to be greater than or equal to 5.5 and less than 6.5. Okay. Question 7b says the length of a different pipe is 4 meters to the nearest meter. Ollie says the total length of the two pipes is 11 meters to the nearest meter. Give an example to show how he could be correct. Well, we know that the first pipe is between 5.5 and 6.5. So let's say if one pipe is up towards the upper end of that range, 6.4, and the other is, well, it could be 4.4, couldn't it? So then 6.4 plus 4.4 is 10.8, which is closer to 11 than 10, isn't it? So yeah, it could be 11 to, what's that, two significant figures. Okay, so he's right. Question 8. This shape is made from 2 triangles and 4 congruent parallelograms. For each statement, tick the correct box. The triangles are equilaterals. Right. We don't know anything about the angles here, but assume if this one here happened to be 120, then this one would be 60. And because these are parallelograms and they're all identical, that one would also be 120, so this one must be 60, so this must be 60. So in that case, it could be that the triangles are equilateral. But however, if the angle wasn't 120, and there are lots of other possibilities for it to be, then it wouldn't be. So it could be true, but it's not must be, and it's not must be false either. Right, the triangles are congruent. Okay, well, whatever that angle happens to be 120 or anything else, it's going to be the same on the triangle below, isn't it? So whatever this angle is here, then so is this one, and so is this one, and so is this one. So that means the angles here and here and here and here are going to be the same, in which case this one and this one are going to be the same. So yes, whatever the angles happen to be, they're going to be congruent. So I'm going to go with must be true. Question 9. There are 720 boys and 700 girls in a school. The probability that a boy is chosen at random studies French is 2/3. The probability that a girl chosen at random studies French is 3/5. Work out the number of students who in the school who study French. Okay, well then we know that the probability of boys studying French is equal to 2/3, and that must have been obtained by dividing successful outcomes divided by total outcomes. Now we know that the total outcomes are 720 because there are 720 boys, and 3 times something is 720. 720 divided by 3 is 240, so times in that by 240 and times in that by 240 would tell me that there must be 480 boys studying French. What about the girls? Probability that a girl studies French. That's equal to 3/5. And we know that the total number of outcomes for girls was 700. And how many times does 5 go into 700? 5 goes into 700 140 times. So multiplying 3 by 140, 140, 280, 380, 420. So there must be 480 boys studying French and 420 girls. So in total, it's 480 plus 420, which is 900. 900 students. Question 9b says, work out the probability that a student chosen at random from the whole school does not study French. Well, we know how many students study French now, so the probability of not French is going to be 1 minus the probability that they study French, which is 1 minus, well, we know that there are 900 students altogether, of which, no, sorry, we know that there are 900 students who study French, and we know that there are 720 plus 700 students altogether, so that's what, 1420. So that must be 520 over 1420, just subtracting one fraction from that fraction from 1. That is a probability. I don't think I need to cancel it down. You don't get any extra credit normally for cancelling down fractions in probability questions, so I'm just tempted to leave it like that, although you do have a calculator that can cancel down fractions for you, so perhaps there's no harm in doing it this time, which is 26 over 71. But like I say, if you've secured all the marks to this point here, then the only thing that can happen if you then go on and simplify it is that you still get 2 marks. That's the upside. The downside is if you make a mistake in this cancellation and you write it down incorrectly, you will then lose that accuracy mark. So like I say, the only possible extra thing that can happen if you cancel down a fraction as an answer to a percentage question is that you can lose a mark. So perhaps you should just leave it like that and play safe. Question 10. A, B, C, D and E, F are straight lines? Yes, they are. Ava assumes that A, B and C, D are parallel. What answer should she get for the size of y? So if AB and CD are parallel, so this one is parallel to this, then what should you get for angle Y? Well, if they were parallel, then this angle here and this one up here are going to be corresponding, aren't they? And therefore they're equal. So 2x plus 10 is going to be equal to 3x minus 2. So we can use that fact to form an equation in x that we can go on to solve. So 2x plus 10 is equal to 3x minus 20. So I'm going to collect the x's on the right hand side to keep my x's positive. If I take x to the other side, I'll get a negative value, so I'm not going to do that. And I'm going to move that over here to keep that positive as well. So that's going to give me 10 plus 20 is 30, and 3x take away 2x is x. That would give me x is equal to 30. So if x is 30, then our congruent angle then is going to be 3x minus 20 is going to be 3 lots of 30 minus 20. 3 lots of 30 is 90, take away 20 is 70. So then this angle up here then must be 70, and so y is going to be 180 minus 70 because they lie in a straight line, giving you a value of y of 110. So 110 if her assumption is correct. 10b says, in fact, A, B and CD are not parallel. Angle W is 60. What effect does this have on the size of angle Y? Okay, right, so if these lines are no longer parallel, let's take those little arrows off because that no longer holds, then W is 60. Let's write in a different color pen so it's different from my working from before. So if this is 60 degrees, then so is this angle over here because it's vertically opposite. So 2x plus 10 is equal to 60. So 2x plus 10 equals 60. So that makes 2x equal to 50, x equals 25. Okay, so if x is 25, then 3x minus 20, 3x minus 20 is equal to 3 lots of 25 minus 20. 325s are 75, take away 20 is 55. So that angle is going to get smaller from 70, what we thought it was before. It's now going down to 55. Okay, so if that angle decreases from 70 to 55, it's dropping by 15, then my angle Y is going to increase by 15. That's going to go up to 125 then, isn't it? Okay, because those two angles are still going to have to add up to 180. So we're saying Y is increasing, and I've got the working here on the diagram, but maybe the marker doesn't see it up there. I think it's probably fine. But just on the safe side, you might want to copy that over into the answer box below. So we said 2x plus 10 is 60. So Y is bigger. We said that 2x plus 10 was equal to 60, which implied that x was equal to 25. So then we worked out the next part. We said 3x minus 20. So 3x minus 20 was 55. Not 70. So 3x minus 20 has decreased by 15. So y will increase by 15 to 125. Question 11. Purple paint is made by mixing red paint and blue paint in a ratio of 5:2. Jan has 30 litres of red paint and 9 litres of blue paint. What is the maximum amount of purple paint she can make? Okay, so the ratio of red to blue is, well, it needs to be 5:2. Okay, so if I increase this ratio, so I increase the amount of red paint required from 5 to 30, I would be multiplying through this ratio by a factor of 6. So I'd have to do the same this side, which means for 30 litres of red paint I would require 12 litres of blue paint, but I don't have 12 litres of blue paint. I've only got 9, so that is not possible. So the best I'm going to be able to do is to make blue equal to 9. So what do I have to multiply 2 to get 9? I have to multiply it by 4.5, don't I? It's 4.5 times bigger. So if I multiply 5 by 4.5, it means, what's that? 5 lots of 4.5, 9, 18, 22.5 litres of red paint. So what's the maximum amount of purple paint that she can have? Well, I suppose when you add 22.5 litres of red paint to 9 litres of blue paint, then altogether you're going to have 22.5 plus 9 litres of paint, which is 31.5 litres. So she's going to have 31.5 litres of purple paint. Question 12. AR to the power of B, all raised to the power of 4, is equal to 16R to the power of 20, where A and B are positive integers. Work out A and B. Okay, well, I've got an index of an index here, so when I apply it over a bracket like that, everything inside the bracket is going to get raised to the power of 4. So A to the power of A raised to the power of 4 is A to the power of 4. R to the power of B raised to the power of 4 is going to be, we're going to multiply those two together and we're going to get 4B. So that's going to give me A to the 4 R to the power of 4B, and I know that's equal to 16R squared. So all we've got to do now is equate the coefficients. Equating coefficients, that gives me A to the power of 4 must be equal to 16. So A is equal to the 4th root of 16, which is going to be 2. And 4B is going to be 20, meaning that B is equal to 5. So A is 2, B is 5. Question 13. In a class of 28 students, the mean height of 12 boys is 1.58 meters, and the mean height of all 28 students is 1.52 meters. Work out the mean height of the girls. Okay, if we know the mean height of the boys is 1.58 and we know there are 12 boys, if we multiply those two together, we'll get the sum of their heights added together, won't we? So the sum of boys' heights is going to be equal to 12 lots of 1.58. So the heights of all the 12 boys are going to add up to 12 times 1.58 is 18.96. So they all add up to 18.96. And we know that the mean height of all 28 students is 1.52 meters. So the height of all students equals 28 times 1.52, which adds up to 28 times 1.52 adds up to 42.56. Okay, so the girls' height then, the sum of the girls' heights is going to be the sum of all students subtract the sum of the boys' heights. In other words, it's going to be 42.56 subtract 18.96, which is 23.6. So we know then that girls' heights add up to 23.6. And we know how many girls there are because there are 28 students. So assuming that the rest of the class that aren't boys are girls, that would give me 16 girl students, and I know that their total height is 23.6. Then the mean height of the girls is going to be that total 23.6 divided by the number of girls, which is 16. Which would make their mean height 1.475. 1.475. Question 14. We're told that x times y is equal to c, where c is a constant. Now, rearranging that for y, that would tell me that y is equal to c over x, which means that y is proportional to 1 over x. So y is directly proportional to 1 over x. It's that one there. Now, if y is proportional to 1 over x, you can say that y is inversely proportional to x, but you cannot say y is inversely proportional to 1 over x. That makes no sense. So don't be tricked by that. Y is directly proportional to 1 over x, or y is inversely proportional to x. Okay, question 15. The graph shows the depth of water in a harbour for 12 hours. D is the depth of the water in the harbour in meters, and T is the number of hours after 9 AM. So you can see that the depth of the water is going up and down over time. I imagine that's got something to do with the tides. There's kind of a bit of a sine curve going on there, isn't there? It's certainly of that shape. So, for how many of the 12 hours is the depth more than 5 meters? Okay, so where's 5? Let's just get a ruler out. So let's just draw a line across at 5. So it's going to be more than 5 hours when it's above that line then, isn't it? So at this point here it dips below it, and at this point here it comes back up it again. So it's going to be more than 5 between 0 and 7, and from 11 till 12. So that is going to be 7 plus 1 hours, isn't it? It's going to be for 8 hours. So 8 hours. Now question 15b says, by how much does the depth change between 12 noon and 4 p.m? Now you might be forgiven from just thinking, well, I need to look up here at 12 and here at 4 and work out the difference between the two. But if you just did that, you would be entirely wrong and you're going to lose marks. Okay, let's be a little bit more careful about this. Now, on this scale, I have got time t hours. That is not the time. So that 4 there doesn't represent 4 p.m. or 4 a.m. What it represents, it tells you up here, look. T is the number of hours after 9 a.m. So this 0 then means 0 hours after 9 a.m. So that is 9 a.m. So then that's going to be 10. That's 11. That is 12. That's going to be 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 8 p.m., and then 9 p.m. So if we want to know the change between the hours of 12 and 7, we actually need to look up from 3 and t is equal to 3 and t is equal to 7. So we've already got the height at t is equal to 3. Look, that goes up to this point here that we already had, so it goes up to 5. And then at 3, reading up from 3, we can see that we get to 8 and across. So the depth then is going to increase or decrease by a distance of 8 subtract 5, which is 3. So by how much does the depth change between 12 noon and 4 p.m? It changes by 3 meters. Very sneaky examiners. Question 16. The value of a new car is £18,000 and the value of the car decreases by 25% in the first year and then 12% in each of the next 4 years. Work out the value of the car after 5 years. Okay, so we're going to have to do, let's do this in 2 steps. I'm going to do a 25% deduction first, and then we can apply this one as a compound interest for the next 4 years. Okay, so doing my little triangle for percentages, FOM, if you've not seen this before, stands for final, original and multiplier. I tend to do all my percentage questions this way, just works for every type. So final is what we're going to get after applying the percentage change. Original is what we start with, 18,000, and multiplier, now this is a 25% decrease. So when you increase or decrease, you start with 100% and then you add or subtract your percentage. This case we're going to subtract 25%, giving me a figure of 75%, which as a multiplier is 0.75. Now once I work that out, I cover up the thing I want to find, f, and then the other 2 things tell me what I have to do with the other 2 things. Final is equal to original times multiplier. Just works the same way as the DST triangle if you use one of those. Okay, so subbing in the values, original is 18,000 and the multiplier is 0.75. Okay, so multiplying those together, 18,000 times 0.75 gives me 13,500. So it loses its largest, it takes its largest drop in the first year. Okay, we've got 4 more years to go now. Now for the next 4 years, the interest rate is staying the same. It's going to be reducing by 12% in the next 4 years. So again, using my FOM triangle, final, original, multiplier. This time, final is going to be, again, what I want to find. Original is going to be my value from before, isn't it? After the first year. So that's going to be 13,500. My multiplier this time, starting with 100%, subtracting 12% per year, which is 88%, which is 0.88 as a multiplier. Now again, final is going to be equal to original, so final is going to be my original 13,500 times my multiplier 0.88, but this time we're going to raise that to the number of years that we're going to apply it. A number of times I need to apply that multiplier. I need to apply it 4 times because it's going on for 4 years. So type that into the calculator, 13,500 times 0.88 raised to the power of 4 gives me £8,095 and 89 pence. £8,095 89. Does it tell me to round it off at all? Work out the value. I'm just going to leave it like that then. Question 17. Liam drives his car. He drives the first 9 miles in 9 minutes. He then drives at an average speed of 70 miles an hour for 1 hour and 36 minutes. He finds this information out about his car. Average speed for 65 miles per hour or less, miles traveled per gallon is 50. For more than 65 miles per hour, miles traveled per gallon equals 40. Use the information to show that his car uses less than 3 gallons of petrol for the drive. Okay, let's have a look at the first stage of the journey. He drives his first 9 miles in 9 minutes. That means he's doing 1 mile in 1 minute. And if he can do 1 mile in 1 minute, he can do 60 miles in 60 minutes. So his speed here is 60 miles per hour. Okay, so he's starting off with 60 miles per hour, which is less than 65 miles per hour or less. So he's going to be doing 50 miles per gallon for that section of the journey. Then he drives his car over 65, so he's going to be doing at the slightly less rate for the next 1 hour and 36 minutes. So let's work out what the amounts are then. So miles traveled per gallon, 50. So if you can do 50 miles per gallon, how much gallons is it going to take to drive for 9 miles? I think I'm going to set this up as a ratio actually. So let's write that down as a ratio. So miles to gallons. We know that I can drive 50 miles for 1 gallon for the first stage. So this is stage 1. So from that I could work out how many gallons I can do in 1 mile by dividing by 50, and then I can scale it up again. I'm using the unitary method here, aren't I? So going via 1, so divide by 50 and times by 9 will tell me how many gallons I need to do 9 miles. It's always going to be a kind of a decimal, isn't it? So if I take 1 and I divide it by 50 and then I times it by 9 as well, then I'm going to do, my 9 miles is going to consume 0.18 gallons. Okay, so that's the first stage of my journey. Now for the second stage of the journey, I'm going to do the same thing. I can now do, because he's going faster than 65 miles an hour for the next 1 hour and 36 minutes. What we don't know at the moment is how many miles he travelled, and well, that's what we need. We need to know how many miles he did in that 1 hour and 36 minutes. So if he's going 70 miles an hour for 1 hour and 36 minutes, how many miles is that then? So DST triangle, distance, speed, time. The distance is what I want to find. I know the speed. The speed was 70 miles per hour. And the time taken was 1 hour 36 minutes. Now, hours and minutes is not so nice, is it? We need to really convert that into a decimal, I think. So 1 hour and 36 minutes. 36, there is 60 minutes an hour, so that's 1 hour and 36 sixtieths. So that's 1 and 36 sixtieths. In other words, it is 60 plus 36, 96 sixtieths of an hour. Okay, and D is what I want to find. So covering up D in my triangle, D is equal to speed times time. So distance travelled equals speed, 70 times time, 96 over 60. So 70 times 96 divided by 60 is 112. So he's done 112 miles. Okay, so now we can set our ratio up then. So again, miles to gallons is, well, we've done, or we can do 40 miles in 1 gallon. Okay, so again, going via 1, that's, and then up to 112 would mean dividing by 40 and times in by 112. So if I do it on that side, I've got to do it on this side as well. Divide by 40 times by 112. So taking 1 divided by 40 times 112, I get 2.8. Okay, so that means we used 0.18 gallons of fuel in stage 1, and we used 2.8 gallons in stage 2. So total petrol used equals 2.8 plus 0.18, which is 2.98. He has used less than 3 gallons. Question 18. Nick sketches the graph of y equals 0.5 to the power of x for x greater than or equal to 0. So we can see that the graph that he's drawn here, and now we're asked to make one criticism of his sketch. Well, there's only one kind of point of interest on this graph marked, and that's that point there, isn't it? The intercept. We get to that point when x is equal to 0. So should we just double check his maths at that point? So when x equals 0, then y is going to be 0.5 to the power of 0, isn't it? And any number raised to the power of 0 is 1. So he's plotted it in the wrong place, or he's put the wrong number on the scale. That number there should be 1 and not half. Okay, so make one criticism is sketch. The y-intercept should be at 1. Question 19. A, B, C, D, and E are points on a circle. BFD and AFC are straight lines, and we're told that DC is equal to DF. Now all that information is already on the diagram, plus we've got a few extra pieces of information. What we need to do is work out the size of angle X, which features here, and it also features again next door here. Okay, so we've got X appearing twice there. Right, so what shapes do we recognize? Well, you should notice that you've got two angles subtended from the same chord, from this chord here. Look, it's one of those bow tie type circle theorems, and with those we know that these angles subtended from the same chord or arc are equal, so that one there must be the same as that one over there, so that one must be 24 as well. So once we know that is 24, then this is an isosceles triangle, so I can find these two angles, can't I? So this one here and the other one, they're going to match, and they're going to be equal to 180 minus the 24 divided by 2. So 180 subtract 24 is 160, 156, and dividing 156 by 2 gives me 78. So that is 78 degrees. So I've got two 78s, so I've got a 78 there and a 78 here. Okay. Now, we were told earlier that AFC is a straight line, so we can use the fact that those three angles must sum to 180. So we know that x plus 2x plus my 78 degrees is equal to 180 degrees. So collecting like terms, 3x is going to be 180 subtract 78. 180 subtract 78 is 102, and 102 divided by 3 is 34. So x is equal to 34 degrees. Question 20. This sign shows when a lift is safe to be used. Total mass of people must be 450 kg or less. Ben and some other people are in the lift. Their total mass is 525 kilograms to the nearest 5 kilograms. Ben gets out. He has a mass of 78 kilograms to the nearest kilogram. Is the lift now safe to use? You must show you're working. Okay, now this question is a limits of accuracy question. You can tell that by these phrases here, to the nearest 5 kg and to the nearest kilogram. Okay, when you see those, it should be screaming out at you, limits of accuracy. So the first thing we should do really is think about what those limits are going to be for our two amounts here. Now we know that 525 kilograms has been rounded to the nearest 5 kilograms. So if we draw a number line and mark on the number they've given us, 525, and this scale is going into the nearest 5 kilograms. So let's mark one up on our scale, which should be 530, and one below on our scale, which should be 520. Now the numbers that round to 525 are going to be the ones that are nearer to 525 than the other two numbers. So anything more than halfway between those two numbers is going to round to 525. So what is halfway between those two numbers? Halfway between 520 and 525 is 522.5. So that's going to be my lower bound, and my upper bound is going to be halfway between 525 and 530, which is 527.5. Okay. For the other measurement I've given, the measurement of Ben, we know his weight is 78 kilos to the nearest kilo. So marking my scale one above at 79 and one below at 77, and using the same thinking, we know the numbers closest to 78 round to 78. So the lower bound is going to be 77.5 and the upper bound is going to be 78.5, and anything in between is going to round to 78. Okay, let's think about everybody in the lift. We've said that they must be between 522.5 and 527.5. Now let's err on the side of caution and consider them to be at the upper bound. Now obviously it can't be precisely 527.5 because that would round up to 530, but 527.4999 reoccurring would round down, so that's pretty much the same thing anyway. So we're going to use that as our worst case scenario, and let's assume that Ben is the lightest he can be, so him getting off the lift or getting out of the lift is going to make the least possible difference. Okay, so then the worst case scenario then is going to be my heaviest group of people and my lightest possible Ben getting off. So 527.5 subtract, so our heavy group subtract our light Ben. What does that give us? That gives me 450 kg exactly. Now the total mass of people must be 450 kilograms or less. So this is the upper bound of the weight of people. Any other case would be less than that, and 450 itself is acceptable as well. So all the possible values that it can be are at 450 kilograms or less. So we can say that the lift is now safe to use just. So the lift is now safe to use. Question 21. Here is a sketch of y equals f of x, where f of x is a quadratic function, and we see that the graph intersects the x-axis at x equals minus 2.5 and x is equal to 1. And we need to circle the solution for f of x is greater than 0. Well, this graph is f of x, and it is greater than 0 for the bit where the graph is above 0. Okay, so f of x is greater than 0 for that section of the graph. Either side of that, it's below 0. But between minus 2.5 and 1, then f of x is positive. Okay, so which boundary is it? So our value of x has to be bigger than minus 2.5. Can't it be equal to 2.5? Because then it would be equal to 0, and it's strictly greater than 0, and it must be less than, strictly less than 1. Okay, so we want x between minus 2.5 and 1. Which one is that? It's that one there, look. Question 22. Work out an expression for the nth term of a quadratic sequence. And we've been given 4 of the numbers, 2, 17, 40 and 71. Give your answers in the form an squared plus bn plus c, where a, b and c are constants. Okay, so we're told straight up this is a quadratic sequence. So in order to work out one of these, now, to find the an squared part of a quadratic sequence, the thing you need to look at first is the second differences. So the first differences are the differences between your two numbers. Here I've got plus 15, and then I've got plus 23, and then I've got plus 31. And the second differences then are the differences of your differences. So from 15 to 23 is plus 8, and from 23 to 31 we've also got plus 8. So you can see here I've got a common difference of my difference of plus 8. Now that means our an squared part of our quadratic sequence is going to be given by a being half that number. So you take that second difference and you halve it, and that is going to be your value of a. So we're going to get 4n squared as our quadratic part of the squared part of that quadratic. Okay. Now the next thing we need to do is work out what the difference is between 4n squared and what we've been given. So we were given the sequence 2, 17, 40, 71. And 4n squared, when n is 1, 1 squared is 1 times 4 is 4. When n is 2, 2 squared is 4 times 4 is 16. When n is 3, 3 squared is 9 times 4 is 36. And when n is 4, 4 squared is 16 times 4 is 64. Okay, so our original sequence, taking away 4n squared, will leave me this part here. It'll leave me a linear sequence, which I can then go and find the values of b and c. So we're going to take this away then. So 2 subtract 4 is minus 2. 17 subtract 16 is 1. 40 subtract 36 is 4. And 71 subtract 64 is 7. Okay, now this should be the linear sequence bn plus c, which we can now go and find the values of b and c for. Because if you look here, the difference between minus 2 and 1 is plus 3. The difference between 1 and 4 is plus 3. And the difference between 4 and 7 is plus 3. So this sequence has something to do with 3n. But 3n is the sequence 3, 6, 9, 12, not the sequence minus 2, 1, 4 and 7. So if I want to get minus 2 from 3, I need to take away 5 from it. If I want to get 1 from 6, I need to take away 5 from it. 9 take away 5 is 4, and 12 take away 5 is 7. So our linear part of the sequence is going to be 3n subtract 5. Okay, that's my bn plus c part. So then the whole quadratic sequence nth term is going to be my 4n squared plus 3n take away 5. That's my nth term. Question 23. Here is a sketch of y equals x squared plus bx plus c. So it's a quadratic function, isn't it? The curve intersects at the x-axis at 5, 0. Now that has already been marked there. And point P, which is over here, look. and the y-axis at 0, minus 10. So there are the 3 points of intersection. Okay. Work out the x-coordinate of the turning point of the graph. Okay. Well, they've already told us something about this quadratic. They told us what the coefficient of x squared is. It's just 1, isn't it? So we know this equation is the form y equals x squared plus bx plus c. Now the plus c part of a quadratic is the same as a linear function. It's going to be the y-intercept. So we actually know quite a bit about this quadratic equation already. We know that c is going to be equal to minus 10. So c equals minus 10 because it's the y-intercept. So that means my quadratic is actually y is equal to x squared plus bx. We still don't know the middle bit, but we do know that that part there is negative 10. What else do we know? We know the roots, or we know one of the roots. It's got a root at 5. That means that this quadratic is going to factorize, and one of the roots is going to be x subtract 5. So if that is the case, then what is the other root going to be? Well, whatever my number is that goes here, when I times it with this minus 5, it's going to give me negative 10. So there's only one number I can think of that I can multiply minus 5 by and get negative 10, and that is positive 2. So that part there is going to be plus 2. So now I know that my quadratic is of the form x plus 2, x minus 5. Now, I don't have to multiply that back out and find b. That's not the job of this question here. It's not asking me to evaluate b and c. What it wants is this midpoint here. Well, it wants to know the x-coordinate of that lower point on the curve. So basically what we need to do is find the value of x here. Now I can use the fact that a parabola from a quadratic equation is symmetrical around its middle point. Okay, so that line I've just drawn is actually a line of symmetry. So the distance between x and 5 is going to be the same as the distance between x and that point P down there. But we know what the point P is now. Because I've put this into two brackets like this, this means that my roots of my equation are going to be x equals 5, which you already knew. But now we know the other one is x equals minus 2. So that point there is minus 2. So we want to find the point which is halfway between minus 2 and 5. So how do we do that? So our mid x value then is going to be minus 2 plus 5 over 2. We're just going to average them out. So negative 2 plus 5 is 3, and 3 divided by 2 is 1.5, or 1.5. So that means our mid value of x is 1.5. Just take a look back at your graph. Imagine 1.5 here. Does it look about right? Yeah, that looks about halfway between minus 2 and 5. I'm happy with that. Let's move on. Question 24. A ball is thrown from a point 6 meters above the ground. The graph shows the height of a ball above the ground in meters. Now 6 meters is probably about roof height of a house. So imagine you're standing on the roof and you throw a ball off the roof. The first part of the journey the ball is going to go upwards, but then due to gravity it starts then falling to the ground and it hits the house, hits the floor a fair distance from the house. Something like that. Okay, what we need to do though is to estimate the speed of the ball in meters per second after 1 second. Okay, now after 1 second the ball is at this point on the curve, isn't it? Okay, now we've got a distance and time graph here essentially. It says height, but it's actually distance from the ground, isn't it? So our speed is going to be equivalent to the gradient of the distance time graph at that point. So what we want to do, because this is a curve and not a straight line, is to draw a tangent on it with our ruler. So you just kind of put your ruler on the curve. So it's, go away. So it's just touching the curve, and you've kind of got equal space either side of it, kind of here and here between the line and your curve. So once you're happy with where your tangent lies, you can draw it on. Okay, it's going to look something a bit like that. And we're going to need to take 2 points on it and evaluate the change in y and the change in x. Now, I would suggest you take a point which lies on one of your known grid references. So I'm going to take this point here that is exactly at 2, and this point here which is exactly at 0. So I'm taking a good length of the line, and so I can be quite accurate. Don't want to put your points too close together. So that's going to be my change in y, and then my change in x is here. So how far is, well, my change in x is easy to do. It's just 2 subtract 0, isn't it? I'm going to quickly do that first. That's 2. What's my change in y? That's a little bit more tricky to read. So that point there, I think, is 2 little squares above 9. Now there are 5 divisions between each unit, so each one must be worth 0.2. So I reckon that point up there must be 9.4. The base of the bottom point of my y line is halfway between 6 and 7. I'm saying that's going to be 6.5. So then the change in y is going to be 9.4 subtract 6.5, which is 2.9. Okay, so then the gradient. So the speed of my ball is going to be equal to the gradient, which is change in y divided by change in x, which was 2 subtract 0 on the bottom and 9.4 minus 6.5 on the top, which was 2.9 over 2, which gives me 1.45. Now, the height was in meters and the time was in seconds, so this must be meters per second. 1.45. Question 25. Rectangle ABCD is the horizontal base of a triangular prism. Where's ABCD? It is here. Look, this is the rectangular base of my triangular prism. Now we're told that AE equals BE. AE equals BE. Now that's not been marked on the diagram, so we need to add that in. These two lines are equal in length, which means that the front face is going to be a isosceles triangle. E is directly above M. That's good. That means it's got a uniform cross section. It is a prism, and the midpoint of AB. Okay. Okay, we did that. And then AB is 16 centimeters. AB is 16. So then it must be 8 from A to M and 8 from M to B, and 16 altogether. What else do we know? A to E is 17. So from here up to here, it's 17. I think we're going to have to work out the perpendicular height, aren't we, at some point? And then BC is our height or depth of our prism, distance between the front and the back face. And I'm guessing we're going to have to find, oh no, we have first show that EM equals 15. Yep, so we've got to do a bit of Pythagoras theorem here. Now that diagram is quite complicated. Let's just take out the bit that we need for this particular part of the question. So let's take out the front face. We know that this is isosceles, This is a right angle. This is 8 and 8, and this is 17. Okay, so we want to find EM, which is this line here, which I'm going to call X. Okay, so it's a shorter side of a right angled triangle. So using Pythagoras theorem, we should know that if a squared equals b squared plus c squared, then 17 squared is going to be our x squared plus our 8 squared. Rearranging that, then x squared is going to be 17 squared minus 8 squared. Now some of the more astute of you amongst you might notice that that is one of the lesser well-known Pythagorean triples. Most students by now should know that the one triple is the 3, 4, 5 triangle, that 3 squared plus 4 squared is 5 squared. You've also got the 5, 12, 13 triangle. But did you also know that 8, 15, 17 is also a Pythagorean triple? If you didn't, it would be a good idea to memorize this, because they come up a lot. Okay, so this one you should already know is going to be 15, but otherwise you could go through the motions and work it out. So x equals 15. Of course, now we know what x is, there's nothing stopping us to find the volume. Oh no, we don't. We have to find an angle. That surprised me. I thought we were going to go on and find the volume of the prism, but at the moment we're finding the size of angle ECM. What one's that then? ECM. Ooh, curious. I'll just get my ruler out and draw that in. Okay, I've already scrawled all over it in red, so let's pick a different colour. Fiddly ruler. So let's go for green. So E, C, and then from C to M. That's interesting. Okay, now I'm going to find this angle here. Now CM is the part of the baseline, isn't it? It's part of that base of the prism, and we were told earlier that E lies directly above M, so this is going to be a right angle triangle, of which we know quite a lot about already, but not everything. We know the height of it. We know this side here, don't we? This side we just calculated to be 15. Now if we knew another length along here somewhere, we could start using some trigonometry to work out the angle, but at the moment we only know one thing and we need another thing. Well, let's first look at this triangle here, MBC. Okay, that's another right angled triangle which we already know the two sides of, so we can use Pythagoras theorem in MBC to work out MC, and once we know MC, then we know two sides of our right angle triangle, and we can use trig to find the angle. So let's take our second triangle out, MBC, and draw it here. That's M, that's B where the right angle is, and that's C. And what do we know about this triangle? We know that MB is 8 and we know that BC is 30. So we know that is 8 and that is 30. So what is the length of that hypotenuse? Again, we're going to use Pythagoras theorem. So using c squared equals a squared plus b squared, then our line CM is going to be 8 squared plus, sorry, CM squared is equal to 8 squared plus 30 squared. So 8 squared plus 30 squared is 964, the root of which is not a nice number. I might just leave it like that for now. Root 964 seems to be a little bit more nice than the hideous thing that it comes out to be. So let's just leave it as the root of 964 for now. It's easier to type into my calculator. Okay, so we know that CM is equal to the root of 964. So now let's take out that green triangle then, the triangle EMC, and draw that one down. So our next triangle is triangle EMC. So that was M down there, that was E, and that was C. That was a right angle. We just found the length of MC. This one is the root of 964. And we found EM in the first part. We found that was 15. And we want to find this angle down here. Okay, so we've got a right angle triangle, and we know two sides and we want an angle, so that's trigonometry. This is the hypotenuse. Don't know about it, don't want it. This is the opposite, and this is the adjacent. So using our mnemonic SOHCAHTOA. Right, which bit is about the O and the A? It's this bit on the end here. Tan is equal to the opposite over the adjacent. So tan theta equals opposite over adjacent. So that is equal to the opposite, which is 15, divided by the adjacent, which is the root of 964. So then theta I'm going to get by doing the inverse tangent of 15 divided by 964. So let's type that into the calculator. Shift tan 15 divided by the root of 964. What's that going to give me? That gives me 25.785, which I'm going to round up to 25.8. I normally give angles to one decimal place unless otherwise told. So I'm going to write that down as 25.8 degrees. Question 26. Here is an L shape. All dimensions are in centimeters. Okay, so we've got this shape here, and we know two of the sides, and two of them are given algebraically. Now we've got some missing sides down here and down here, but we can usually work those out from the other sides, can't we? So for instance, this horizontal distance is the difference between 10 and x, so that side is going to be 10 minus x, and this one up here is going to be the difference between 9 and 3x plus 1, so it's going to be 9 take away 3x plus 1. I don't even know if that's relevant yet. I should go really and find out what the question is. It's probably got something to do with it, isn't it? So the area of the L shape is 65 centimeters squared. Work out the value of x. Okay, so we need to work out the area of this square shape, this L shape. So what I can do is I can divide it into two parts and then work out the two parts and then add them together then, can't I? I'm just trying to decide which way around to do it. If any of it gives me nicer numbers than anything else. I don't think so. Let's just divide it this way. At least I get one nice piece. So that part there is 9 times x, isn't it? So that part there is going to be 9x. And this other section is going to be 10 minus x times 3x plus 1. So that's going to give me a quadratic, isn't it? So this is 10 minus x times 3x plus 1. I'd have to work out what that is. So the combined area then is going to be those two things added together. So area of my L is equal to my 9x plus the brackets, which now I've forgotten again what's in them, 10 minus x and 3x plus 1. 10 minus x, and 3x plus 1. Okay, now I know that's equal to 65. So I suppose I just need to multiply these out, these two brackets, and combine it with the 9x and the 65, and then we're going to have a quadratic that we can then solve for x. So that's my plan of action. Okay, so let's multiply out the quadratic first. So my 65 then is going to be equal to 9x, which was already there. Then I've got 10 times 3x, which is 30x. So plus 30x. I've got 10 times 1, which is plus 10. I have got minus x times 3x, which is minus 3x squared. And I've got minus x times 1, which is minus x. Okay. So just collecting like terms on the right first. I've got 30x plus 9x take away x, which is 38x. I've got my minus 3x squared, and I've got plus 10. Okay. Now, because it's a quadratic and I want to solve it, I want to get everything equal to 0. And the easiest way to do that is to move everything onto the other side so that my minus 3x squared term becomes positive. So I'm going to move all three terms over the equal sign. Right, putting them in order, moving the minus 3x squared over first, that becomes 3x squared, positive 3x squared. My positive 38x becomes minus 38x, and my 65 subtract 10 becomes plus 55, and that is all equal to 0. Now it'd be lovely if this factorized, and it's always worth giving it a decent go before you give up and go for the formula approach. So if it did factorize, we would have 3x here and we'd have x here. Factors of 55. What are the factors of 55? Not that many, I suppose. There's 1 and 55, and there is 5 and 11. And I think that is probably about it. So, can I make 38 by popping those numbers in somehow? Now, because we've got a positive last term and a negative term in the middle, the only way that can happen is if both terms here are negative. So these both have to be negative numbers. So let's just try those numbers in. If I put the 11 in here and the 5 in here, then 3 times 11 would be 33, and 5 plus your 5 would give you minus 38 then, wouldn't it? So that does actually work. Happy days. I don't have to do the formula. Okay, now if in an exam you struggled and you couldn't find, or you tried to factorize it and you fail, you can always fall back on the formula. There's no reason why the formula won't work. It's just long. Better to factorize it if you can and avoid using the formula if you can. But if you can't, then you just have to bite the bullet and do the formula. Okay, but we managed it here, so that's good. So if 3x minus 5 times x minus 11 is equal to 0, if two things multiplied together give you 0, it means that one or the other of the things must have been 0 to start with. So 3x minus 5 equals 0. What does that mean? That means 3x is equal to 5, x equals 5/3, or x equals 11. That one's easy. So they're my two solutions, x equals 5/3 or x equals 11. Now, just because a number is a solution of a quadratic doesn't necessarily mean it's a solution to your problem. Let's just go back and have a look at 5/3 and 11 in situ. So going back and looking at the diagram. Okay. Now, if x is 5/3, no problem. But if x is 11, what do you notice? Well, if x is 11, then this side here is 10 subtract 11, which is minus 1. And now in the context of this question, x equals 11 doesn't make any sense. Okay, so whilst it is a solution to that quadratic, it is not a solution to the problem. So we're going to have to rule this one out. And I'm going to write underneath not possible to show that I considered it and decided against it. So the answer is 5/3. Question 27. Prove that x squared plus x plus 1 is always positive. Now, there are quite a few different ways of going about this. The way I think I'm going to look at it, I'm going to think of this as a quadratic equation, y equals x squared plus x plus 1. Now, this is, everything's positive, isn't it? So it's going to be a kind of a smiley parabola this way around. And if it's always positive, it means it is always above the x-axis. Don't know where the y-axis will be. So how can we prove then that that quadratic curve or that parabola is always above the x-axis? Well, if we can find this point here, the lowest point on the curve, and show that that is positive, then we can, well, we can say that x squared plus x plus 1 is always positive. So how do we find the turning point of a quadratic? We need to complete the square. So rewriting this as x plus something squared. The something squared you get from looking at the x term here, don't you? It's the coefficient of that term divided by 2. So the coefficient of x here is 1, and taking 1 and divide it by 2 gives you a half. Now, if I want to replace x squared plus x with x plus a half all squared, I'm introducing a half squared more than I should, so I need to take that off again. Plus I've got my 1 from before. So that is equal to x plus a half squared. Well, minus, what's a half squared? A half times a half is a quarter, plus 1. And that gives me x plus a half all squared. What's minus a quarter plus 1? 1 take away a quarter is 3/4, so that's plus 3/4. Okay, so then this graph here then is going to have, so graph has a minimum point at, well, what's the x-coordinate and what's the y-coordinate? The x-coordinate is given by this part of the expression. It's the value of x that makes that bracket equal to 0. So if I let x be minus a half, then minus a half plus a half would be equal to 0, and 0 squared would be 0, and that would be the least possible value of that expression. And if that bracket were 0, then this part here would be our y value. So our y coordinate is going to be 3/4. So this point up here then is minus a half 3/4. And you can see then that 3/4 is going to be the lowest value that the expression can take. And therefore every value of x squared plus x plus 1 is always going to be that value or more than that value. In other words, it's always going to be positive. So how can I write that down? So x squared plus x plus 1 is going to be greater than or equal to 3/4 for all values of x. Not sure that's why that's there. All values of x. So x squared plus x plus 1 is always positive. And we're done. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.